Anybody know? Anybody want to fill out anything? Go ahead. What do you want to fill out up here? Basic areas. Let's go. What do you want to fill out on your own? We're in trouble then, huh? All right, Saad? Triangle, sure, I got you. Go ahead. Yep, half base times height. Base times height divided by 2, some people may write. Anything else up here? Let's go, James. Here you go, length times width, rectangle. Maybe one more, I would think. Stacy? Yep, pi r squared. Yep, pi times radius squared. That's what I figured the 3 were. Anybody want to go any more? Try one out. Parallelogram. Base times height. Trapezoid. 1/2 the height times the 2 bases added together. So I'm going to put B1 and B2. And just so you guys know, B1 is base number 1, and B2 is base number 2. There's 2 bases in a trapezoid. And kite rhombus, I'm going to write it down. You let me know what the variables mean. 1/2 D1, D2. Any ideas what you think D represents? Think about it. It's a kite and a rhombus. What do they have in them that might start with the letter D? Hi, Maya. Diagonal lengths, yes. Ready to roll? Find the perimeter in the area of the parallelogram. All right, perimeter in the area. Let's start perimeter first. All 4 sides added up. Got to use some parallelogram properties here. Got to use some parallelogram properties. What's another side in that parallelogram that you know? 28? 23, opposite sides are congruent, so this one's 23 feet. Nice job. Ooh, I do not know about the other 2 opposite sides, but I gave you some other information on the side over on the left. How can you use that 7 and 24 to find the other side lengths? 12? Little Pythag, yep. So 24 squared plus 7 squared equals the other side squared. Here you go. Let's roll. What's the other side length? 27 when you're ready. 25. All right, so my perimeter, 2 times 23 plus 2 times 25. 25. And what are you guys looking at there? 17? 96. 96. Feet. Thank you. All right, let's tackle the area now. If you look back up top, the area was base times height. All right, I got a lot of numbers working here. Which one should I pick as the base and the height? Here's what I'm going to tell you. In a parallelogram, the height perpendicular to the base. Height always perpendicular to the base. The height is always drawn to the base. Okay? Height drawn to the base. So if you could pick off the base and the height, which ones are you going to pick off here? Height is drawn to the base. 5? Oh, nice. Here you go, 25. Okay, yep, perfect, because the height of what is drawn to it? Which would be, what's the height? 24. Everyone see this right here. The height, which is perpendicular, so I know this is going to be my height, is always drawn down to the base. And why am I not using 7? Why am I not using 7 here? Because 24 is drawn to 7. Why am I not using the 7 then? Is it part of the parallelogram? No, it's not a side. All right, it's got to be a side of the parallelogram. All right, so the height is going to always be drawn to the base. So this ends up being, and now I got to focus back here because this is the first time we're talking area this year. 24, what'd you get? 552. Now I'm going to be a little picky this unit. Real picky, actually, because it's not feet. It's always square units when you find the area. Square units, all right? So be careful of that, square units. Right, any issues right now? Because, yep, you see the numbers plugged in. Skylar. Why is this 23? It's a parallelogram. What's one property of a parallelogram? The main. Yeah. I don't know. I don't know this. 24 is not a side length. This is the actual side length right there. So that's why I had to use Pythag. Good? All right. A, find the area. Base, height. Do you guys know the base or the height at all? Here you go. 8 are the base or the height given. Good. Base is 17. Hey, everyone, take a look. Everyone sees the height perpendicular to the base. Well, this base isn't labeled, but if that's 17, Ethan knows, all right, opposite sides are congruent. This one's got to be 17. Yep. Ooh, are you ready for the height? Hi, Evan. Darn, no, not could. We are doing a 45, 45, 90. Yep. All right, so let's set up our rules. You're going to remind everyone of your rules there, Evan? Good. What side do you know, Evan, in that 45, 45? What side? Yeah, what side length is given in that 45, 45? And what angle is it across from so I can put it in my chart? Okay, so I'm going to put a 9 in one of the 45 columns. What goes in the rest of my chart now? Here you go, 13. What goes across from the other 45? 9, and what about across from the 90? Okay, so out of these values, which one's the height? Out of these three values, is it 9 or is it 9 radical 2? Which one's across? Where's my height across from? You guys tell me. Here you go, 23. Where's the height across from? It's across from the 45. So what's the height? 9. There we go. With the proper units, the area of that parallelogram with proper units, 8. Yep. Please don't make sure you square. Do not square the 153. It's the units that get squared, not the number. All right, B. Now I got a 3060 on my hands. What's the 32 represent in the diagram? 32. 11. What's the 32 represent? Base, okay. So everyone ready to find the height? 30, 60, 90 triangle. Anybody want to remind your classmates of the rules? 24, remember the rules? And 2x. 2x. Double the side across from 30. All right, where's the 12 located? Where am I going to put the 12 in my chart? 27, where am I going to put the 12 in my chart? Okay. 12. Anybody want to complete the diagram? 4, complete this diagram for me. What's across from the 60? Yep, and across from the 90? 24. Which one of these three do I want? Where is the height across from in this one? Height's across from 14. It's across from the 60. What's across from the 60? 12. Radical 3, round to the nearest tenth if necessary, which it will be on this one. $22, what do you got? Nearest tenth? There they go. And the units. I like it. All right, because odds are in an honors class, you're not going to get a basic area problem. You'll get something with a 30, 60, 45, 45 we've done before. Any issues? Okay. Perimeter and area of each shaded triangle now. Each shaded triangle. All right, let's go perimeter. Shaded triangle, the shaded one. So right here I have 19 plus 41 plus something. Everyone see we're missing that third side of the shaded triangle. I got the 19, I got the 41, but I got to find the missing side. Thoughts on how I can find that missing side? 14, how can I find that missing side right here? Pythag, yep. What's it going to look like, Nate? Yep. Guys, that's not going to come out to be pretty, so I appreciate just leave it in radical form right now. All right, that's not going to be a perfect square. You're going to take the square root of. Hopefully we're getting square root of 1629. Square root of 1629. All good? Okay, there are, hey, let's get Regents mode right now. There are no rounding directions, so anybody remember from middle school, rounding directions? If there's none there, write out your full calculator display. Okay, let's get in that mode right now. If none are given, no rounding directions are given, we're going to write out the full calculator display. I did 27 squared plus 30 squared and got 1629. It says the shaded triangle, right? Well, you can't because it's not a right triangle. Pythag won't work. Oh, not square inches. Calm down. Look good? Issues? Ready for the area? Okay, it's a triangle now, so new formula, 1/2 BH. Same thing. Hey, the height's going to be drawn to the base. Height is going to be drawn to the base. Everything is given to you here. So I'm going to ask somebody, what's the height and what's the base of that shaded triangle? The height is drawn to the base. And the height is there. It's just not inside the triangle. All right, let's talk 4. Let's talk. Where do you think the height and the base are for that shaded triangle? Darn right it is, because that's perpendicular to a base of what, Skylar? On the shaded triangle now. I don't want the 27 because that's not part of the shaded triangle. So the 30 is drawn to a base of what? 19. Got it. Everyone soak that in right there. Take a look. The base has to be a side on the triangle. And in this case, yes, the height's on the outside. Must be an obtuse triangle. And what are we looking at? 71.7415, running out of room. 3566. Nope, that's the next problem. Not even close. Anybody gonna stop me there? Again, I probably could have just wrote chair and you guys would have wrote it down. How about I look at this one and not the next problem? 285 square inches. How about that one? Try out B on your own or in your group. Let's see what you got. I'll just write the answers up here. Find the perimeter of the shaded region. Guys, you have to do a couple Pythags here. Talk it over with your group if you need to. Talk it over with your group. Might be easier to talk it through. We doing all right? What do you guys notice when you're dealing with the right triangle? Anybody know another name for the base and the height that you used? What are these of the right triangle? Those are my legs. Yeah, so anytime you use a right triangle, the base and the height are the two legs of a right triangle. Okay, so just something to keep in mind when you're dealing with the right triangle and finding the area, the base and the height are the two legs. No issues before we go to DeAndre and some mulch. All right, let's put this to, let's put a little real world use, huh? I'm sure. Little DeAndre is going to be mulching his garden there, the triangular garden. He knows one bag is going to cover 12 square feet. How many bags is he going to need? Well, how am I going to know if this is a perimeter or an area question? How much does one bag cover? 12 square feet, meaning what type of problem am I working with then? Area. All right, so I need your help first finding the area of this triangular garden. 1/2 base times height. There's no Pythagorean theorem needed here because the base and the height are already labeled for you. You just got to pick the right ones. Look at the height. Where is it drawn to? Where's the perpendicular segment drawn to right now? So where's the base and the height of that triangle? Here you go. 4, base and height. You're on fire today. Darn right, because the height of what is drawn to it? 9. Everyone see height of 9, perpendicular to the base, 7. So his area, 31.5 square feet. All right, let's determine how many bags he's going to need. And this doesn't drive me nuts, but this is an issue for kids. Do I multiply or do I divide by what they give me? That's the big question, right? One bag covers 12 square feet. This is how many square feet you guys have? 31.5. So what should I be doing with the 31.5 and the 12 square feet? 18? Darn right. All right, so the number of bags is going to be that 31.5 square feet divided by 12 square feet per bag. Go to my calculator, 31.5 divided by 12. I get 2.625, right? I hate to break it to people, but I'm not going to roll over to Home Depot today and be like, hey, bud, can you give me 0.625 bags of mulch? All right, I'd probably get ridiculed if I asked that. All right, we're talking whole bags of mulch. So how many full bags of mulch am I going to need to cover this whole thing? I'm going to need 3 bags, and not because 2.6 rounds up to 3. All right, if this was 2.1, how many bags would I still need? 3. Okay, 2 wouldn't cut it. All right, I'd be short. All good there. All right. He's master landscaper here, DeAndre, master landscaper. Now he's going to pave, he's going to get paving stones to border the garden. And 1 paving stone is 4 inches. What do you mean by pave the stones to border his garden? Now we're going from area to what? Okay, I don't know if anybody sees this little glitch we're going to have in a second. Perimeter, no big deal. I have all 3 sides, 23 plus 7 plus 15. That garden's got a border of 45 feet. You superstars that are dividing by 4 right now, you might want to wait. Anybody see a little mix-up right now that you got to see very, very carefully? Go ahead, Ella. Yeah, it covers 4 inches. A stone covers 4 inches. We got 45 feet. Ready to convert then. All right, 4 inches for every stone, not feet. So how do you want to convert the feet into inches? Multiply it by 12, yep. Trick A. So how many inches do I have? 540 inches. Now you can say, all right, how many stones do I need? $540 divided by 4, he's going to need 135 stones. Questions from you guys? Going? Okay, here's what I'm going to do because I'd like to go over some Regents questions now. You guys, for your homework tonight, have packet page, what is it, 6 or 7? 6. Can you just save that for tomorrow night? All right, I'll get into this population density first thing tomorrow. All right, I just don't have the time to thoroughly go over it right now. All right, so save packet page 6 to tomorrow. All right, so the first thing we'll do for notes tomorrow is the population density. Okay, so for now, let's get out your Regents exam. We'll go right to the bell. All right, so save packet page 6 till tomorrow. Tomorrow night's homework. All right, go to number 10 on that Regents I just given you. All right, read through number 10. We've got a dilation going on of a line. What happens to the line? All right, what happens to my line? See if you can think about the correct answer. We'll go over it right now, though. Okay, ready? We're going to dilate it around the origin, which is perfect because, hey, we'll remind ourselves, anytime you dilate around the origin, what do you do with the coordinates and the scale factor? Anytime I dilate around the origin, what am I doing with the coordinates? So 1, 1 and scale factor 3. What can I do to find the new coordinates if it's around the origin? Multiply them, all right? So 1, 1's going to 3, 3. I'm just going to guesstimate here. 3, 3. And 5, 7's going to go to 15. Woo, buddy. 15, 21, right? And you don't need to do this. I'm just trying to show you a visual here. What's going to happen? It's not the same line, obviously. Doesn't pass through the origin, but they are going to be parallel. All right, that is anytime you have a dilation. All right, anytime. Corresponding sides or lines stay parallel. Okay, can't stress that enough. Anytime you dilate, corresponding sides or lines are always going to be parallel to each other. All right, they're not going to become perpendicular. We okay on that one? Seemed pretty easy? Great, go to 16. Let's see if you think this one's pretty easy. Find the measure of angle A. You are in a right triangle, so you have a bunch of options. You are in a right triangle. A lot of options right now. Just want to see what's going through your mind right now. Anything at all? 25? I got the 9 and the 14 there. It's a right triangle. Okay, what's the 9 then? Because you have opposite, hypotenuse, and adjacent when you talk Sohcahtoa. What would be the 9 in relation to angle A? Okay, and what would be the 14? Yep. All right, so if we're choosing to use Sohcahtoa, If you remember how to spell it, what goes with A and H? The C, which stands for cosine. Here we go. Cosine of angle A, 9 over 14 or 14 over 9? Adjacent over hypotenuse, 9 over 14. And then specifically, what are you guys doing in your calculator? Inverse cosine. 9 over 14. Make sure you're in degree mode. I don't know if you've been playing around in your calculator. You should never be out of degree mode anyway. Stuck in degree mode. And then angle A turns out to be 25? 50 degrees, yep. Okay. Questions? All right. Again, leave page 6 in your packet till tomorrow night. Just work on the bookwork.